Hello everyone. In today's lesson we're going to work through a law of multiple proportions problem. In this example we have two elements, copper and chlorine, combining to form two different compounds. And you see the percent composition for compounds A and compounds B here in the problem. We're trying to solve for the lowest whole number ratio of chlorine that combines with a given mass of copper in this example. So the first thing that we need to do is to figure the ratio of mass chlorine per given mass copper for each of the two compounds A and B. And we're given percent mass information for these two compounds. So what I need to do is take those mass percents and turn them into actual masses. Now, percentages can be used to find actual masses for any sample size. The easiest one mathematically would be 100 grams. So the first thing we're going to do here in our problem is to assume we have 100 grams of each of our compounds A and B. So then if we look at compound A, if I have a total of 100 grams in my compound, I'm going to have 64.20 grams of copper. And I'm going to similarly have 35.80 grams of chlorine. So now I've taken my mass percent, turned it into actual masses, which I can use to figure out the ratio of mass chlorine to mass copper for compound A. So that's what we're going to do next. We're going to set up a ratio. Now notice in the problem here we're looking for the ratio of chlorine that combines with copper. So in my ratio I should have the mass of chlorine in the numerator and the mass of copper in the denominator based on the information that's given here in the problem. So let's see, we've got 35.80 grams of chlorine in compound A. We have 64.20 grams of copper in compound A, and then I just need to divide through. This ratio is in decimal form, 0.5576, and the label here would be grams chlorine per gram copper. So what that means is for each 1 gram of copper, compound A, we will see 0.5576 grams of chlorine combining with it. So we're going to keep that ratio, kind of set it aside for now, and we're going to do the same thing for compound B. So let's write our ratio for compound A up here so we don't forget it. 0.5576 grams chlorine per gram copper. And then we're going to go ahead and do the same thing for compound B. So again, we're going to start by assuming that we have 100 grams of compound B. And then that would give me, based on the percent mass, 47.27 grams of copper and 52.73 grams of chlorine, based on the mass percent and 100 grams of compound B. And we'll once again form a ratio here. And again, we need grams chlorine over grams copper based on what we're being asked in the problem. We're looking for the ratio of chlorine that combines with copper. So chlorine goes in the numerator, 52.73 grams, and copper in the denominator, 47.27 grams. Oop, don't need grams in there twice. Get my eraser. There we go. And just like we did before, we're going to calculate the ratio in decimal form. So dividing through, we get 1.116 grams chlorine per gram copper. So now I have the ratio of grams chlorine per grams copper for compound A, 0.5576 grams chlorine per gram copper, and compound B, 1.116 grams chlorine per gram copper. That's compound B. And let's make sure everybody can still see the 1 here. That is 1.116 grams chlorine per gram copper. Now, I'm not done. I have the mass chlorine per given mass copper ratio for both compound A and compound B, but what I now need to consider is the law of multiple proportions, which says that these mass ratios should reduce to a simple whole number ratio. So let's take a look at how we do that. I'm going to rewrite my ratios. Remember, for compound A, we had 0.5576 grams chlorine per gram copper. And for compound B, we had 1.116 grams chlorine per gram copper. So I want to take these two ratios and express them as a new ratio, which should reduce to a simple whole number ratio in accordance with the law of multiple proportions. Now, you could technically set this up either way. What I'm going to do is take the larger of the two ratios and put it in the numerator of my ratio. So notice the larger of the two ratios was compound B. So what I'm going to do here is set up a ratio of compound B to compound A in terms of the mass chlorine per given mass copper. So I've got 1.116 grams chlorine per gram copper for compound B, and I have 0.5576 grams chlorine per gram copper for compound A. And so what we can see off the bat here is that my units, grams copper per gram, or excuse me, grams chlorine per grams copper, will cancel. So this final ratio is going to be dimensionless, and then we can go ahead and divide through 1.116 divided by 0.5576, and this comes out to be approximately a 2-to-1 ratio. So we do see that those mass ratios reduce to a simple whole number ratio, in this example, a 2-to-1 ratio. And that would be, again, the ratio of the mass chlorine to mass copper in compound B to compound A is what we're looking at based on the way we've set up the ratio. If we had set up the reciprocal ratio, we would have gotten a 1-to-2 ratio, which is still a simple whole number ratio. I like to put the larger of the two mass ratios in the numerator. Okay, so that's a law of multiple proportions calculation. If you have any questions, either email me or stop by before or after school, and we can take a look.